Hey folks, in this video we're going to look at a problem where we are reacting elemental sulfur, which is indicated here comes as S8 octatomic, meaning there are 8 sulfur atoms in the molecule, which we'll write that way, and reacting with fluorine, which is a diatomic molecule in nature, to form sulfur hexafluoride. Sulfur hexafluoride means we have 6 fluorines in this particular molecule. So that is our reaction. Now, again, what we're trying to figure out is how much fluorine we need to react with this. So we need to first balance the reaction. That's going to be our first step always, is balancing our chemical reaction. We write the reaction and then we balance the reaction so we have the same number of atoms on both sides of the equation. So the first thing we'll note is that we've got 8 sulfurs on the left side, and we need 8 sulfurs therefore on the right. So I'm going to put a stoichiometric coefficient of 8 in front of our sulfur hexafluoride. Now, let's look at fluorine. We have 2 fluorines on the left, but now I've got 6 times 8. We've got 48 fluorines on the right. So we need to balance it, therefore. We're going to need to multiply our F2 by 24. Here, and let me erase that and make a little bit more room here. So now I've got 48 fluorines on the left and 48 fluorines on the right. So we're all good. We have a balanced chemical reaction. So the first step was balancing the reaction. The second step then is calculate the moles of our given material. Which in this case is S8. As we start with 17.8 grams. All right, so in order to calculate the number of moles, what do we need to do? We need the molar mass. So we need to go to the periodic table and look up the elemental mass, the atomic mass of sulfur, and multiply it by 8. So our molar mass is going to be 8 because we have 8 sulfur atoms times 32.06 grams per mole. That's going to be the molar mass of S8. So with the molar mass of S8, 8 times that is going to be 256.5 grams per mole. All right, so that is the molar mass of our S8. Now, how do we calculate the number of moles? So the number of moles is going to be our mass of 17.8 grams divided by our molar mass. And again, using dimensional analysis, we have 256 grams of S8 per mole. All right, grams cancel out. We have the grams in the denominator. And so we run through that calculation, and the number of moles that we get is going to be 0.0694. And actually, if we want to keep sig figs, we're going to have 3 sig figs, so 0.694 moles of S8. All right, so that's the number of moles of S8, so good. So we finished the second step. We know the number of moles of our reactant. that we're given. So what we're trying to figure out is how much fluorine we need to react with that. And so how do we do that? Well, we need to know the mole ratio, which is what we get from our balanced chemical reaction. All right, so we're going to do step 3 is the moles of fluorine. That's the desired, in this case, whatever it is we're trying to calculate in general. So in this case, it's fluorine that we're trying to calculate. So what's our ratio? So the moles of fluorine, all right, is going to be, we take the moles of our S8, and we note from our stoichiometric relationships here that for every mole, what this reaction means is that for every mole of S8, I need 24 moles of diatomic fluorine. So that's the stoichiometric coefficient of 24. So I'm going to use that relationship. I'm going to note that I've got 1 mole of S8, and I'm going to put that in the denominator because I want the moles of S8 to cancel for 24 moles of F2. So when I do that calculation, all right, what I'm going to get for my moles of F2 is 1.67, rounding off 1.67 moles of F2. All right, so that's what I've got, 1.67 moles of F2. So that's step 3. So again, to reiterate, first step is balancing our reaction. Second step, calculating the moles of what we're given. Third step, calculating the moles of what we're trying to find. In this case, it's F2. And we use the molar relationship from the balanced reaction to do that. And then finally, step 4 is calculating the mass of our fluorine. We have the moles, so to calculate the mass, we need to know what the molar mass is. So we have to go to the periodic table again. So the molar mass of fluorine is going to be 2 times the atomic mass in the periodic table. And the atomic mass in the periodic table is 19.00 grams per mole. Again, rounding off to that value. So 19.00 grams per mole. So we get a molar mass of 38 grams per mole. All right, and so now we're going to calculate the mass of fluorine. And that's going to be our moles, which we calculated to be 1.67 moles of fluorine. And we're going to multiply it by our molar mass, 30.00 grams per mole. And again, just to remember, sometimes if you're not sure about whether I'm going to multiply, I'm going to divide, work with the dimensional analysis. Get the units to cancel. What do you want to disappear? You want that to be in the denominator. So we're going to disappear our moles because they're going to cancel out, and we're going to be left with grams of F2 as our result. So when we do that answer, our answer is 63.3 grams of F2. So that's how much fluorine we would need to react with 17.8 grams of sulfur of S8 to completely react with that. As always, let me know if you have any questions. See you later.